Good evening. In previous session, we have seen the concept of method resolution order. In that, we have used the algorithm called as C3 linearization algorithm. So the algorithm can also be called as C3 algorithm, or we can also call it as linearization algorithm. So I have taken few examples to make you understand about that method resolution order in previous session. So in today's session, we are going to see about super function, and also we are going to see about overriding concept also. So first let us see what is meant by super function. So in Java we are having a keyword called as super. So there super can be used in two ways in Java. One is for accessing the members of superclass, and also to call the superclass constructor we can use the concept of super. This is in Java. So now in our Python, we are going to see a function called as super function. So what is the need of this super function in our Python means? So from child class or in child class, or from child class, I will write from child class, we can access the members of, we can access the members of, we can access the members of parent class. We can access the members of parent class by using super function, by using this super function. So here there is one small restriction is there, that is everything can be accessed. That means every method and every variable can be accessed, but only one cannot be accessed, that is but instance variables. This is very important point about the super function. Only these instance variables cannot be accessed, cannot be accessed. So for that we have to use self. So to access instance variables, we have to use self. We have to use self. So now see here, first point about the super is super function is used to access the superclass members from the child class. That is, if I am going to consider two classes, one is class A. Uh, 1 minute. Okay, let us take here. Let us take one as class A, another one is class B. So where B is going to extend the properties of A. Here B acts as what? B acts as a child class, and A acts as what? It as a parent class. So here from this class, from B class, if I want to access the members of class A, then I can use this super function. So everything I can access from this class B. That means the members of class A can be accessed from the class B by using super function, but only these instance variables cannot be accessed. So if you want to access these instance variables from this child class, then what I have to do? I have to use self variable. Already we know this concept, how to access the self variables, and how to access the instance variables. Already we have seen in our variables concept. So this one point we have to clear, that from child class we can access every member of its superclass by using super function, but only instance variables cannot be accessed. So to access those instance variables from the child class, we have to use a self variable. So by seeing the examples, we can understand clearly about this self variable and about instance variables. Okay. So now I will take one small example. Here I will take two classes. One is class parent. I will take, so in this I will take some variables, that is A equal to 100. I will take, this is a static variable, that is we can say it is a class variable that is directly written inside a class. And one more method I will take, instance method one I will take. So here I will write self. So inside this I want to create one instance variables. So already you know how to create a instance variables. So self dot A equal to 10 I am going to write here. Now second class, that is child class, I want to write here. So child of I am going to write parent here. That means here child is subclass and parent is superclass. Here I want to define a constructor def underscore underscore init underscore underscore in bracket. What should we have? We should have self. Now observe here. Now from here I want to access. This is what child class. From the child class, I want to access superclass members. How can I access? By using super function, I can access. So dot, I want to access M1 function. So first let us see whether it is possible or not. So one at a time I will explain. So first I will create what? Child class object. Some x equal to child I am going to create. This is which object? Child class object. So just I will execute this one. So whenever this is going to execute, what happens? The constructor that is present in child class is going to be executed. In that, what is there? We are going to call M1 of whom? Superclass. This indicates what? Superclass. So now what should be the answer? Here I am not going to print anything. Just I will print one statement here. That is, here I am going to print parent class. Just I will print parent class. I am going to print. Okay. Now just I'm saving it and I'm executing it. So see what is the answer we got? Parent class. So how it is done here? When I'm going to create a child class object, automatically it will go to where? Constructor of child class. So inside that constructor of child class, what I am calling? I am calling M1 method of whom? Of superclass. So here by using this function, I can call this M1 method. Okay. Right. This is first point we have to understand. Next, I want to access A here. Okay. That means what here? How many A's are there? 2 A's are there. Now let us call from this constructor I will call, or from the subclass. If I call A, what happens? Let us see here. Just I will print this one so that directly I will get this one. I will get the value here itself. So whenever I am going to create an object, automatically the constructor calls. Inside this constructor, I am calling superclass A. So observe carefully here, because here we got what? Answer as 100. So A value is what? A value we are having 100 and also 10. But which one is going to be accessed here? Only class variable is going to be accessed, but this instance variable is not going to be accessed. Already I told you to access the instance variables. How to access them? We have to access it by using the self variable. So here I have to write what? Self dot A I have to write. So in first case, what is going to be printed? The superclass A. That means it is visible for the class variable can be accessed by using this super function. So to access the instance variables, what I have to use? I have to use self variable. So in first case, we are going to get 100. In second case, we are going to get 10. Let us observe it. Okay, see, in both cases, what we got? We got 100 only. So here, just let us see what happens here. Why it is going to give you both as 100. So before calling this one, let us take, just I will remove this one and let us check once by taking only self.a. Here again it is going to print what? It is going to print 100 only. Reason, let us check here once. Okay. So here what happens? I have created a child class object. So child class object is going to be created here. The name of this one is X here. Okay. After this, why here we are not getting this A? Reason is I have not called this function. So that if I call self dot A also, we are going to get answer as what? 100. If you call self dot A, it is going to consider this one only. If I am going to call super dot A, it is going to consider what? That 100 only. Reason is when this particular what we can say, this instance variable is going to be created, once we call that particular method, then only instance variable is going to be created. So first I have to call that. Okay, just I will call that method. So here I'm going to call super, just I have removed that so that we got a 100 as output. Now if I call this one M1, now observe what happens. If I call this one, instance variable is created. So if I call self.a, then what happens? Automatically you will get 10 as answer. Now observe. In first case we got 100, in second case we got 10. Second case is nothing but what? Self.a. Self.a is nothing but instance variable is going to be considered. Super.a is nothing but what? This class variable is going to be considered. So by seeing this example, we can understand three things. One is, for accessing the members of, that is nothing but for accessing the instance method, I can use super. Okay. And also for accessing the class level variables, I can access super function. But to access this particular instance variables, compulsory I have to use self.a. For example, I will remove this one. I will remove this one and I will call in this way. Let us see what will be the output. Okay. Now observe here, we got an error. Reason is, whenever I am using super object, then it will go to superclass and it will search for A. Is there any A here? Not there. Here A is there, but here if I want to access this, I have to use what? I have to use self. So now if I comment this one, we will not have any errors here. Just I will comment this one and I am going to execute this. Okay. Now observe, name SC is not defined. Sorry. Here I have pressed unfortunately yes. So now see. So we got what? Answer as 10. There is no problem. But when we are going to get the problem, when we are going to access the member of parent class without that particular A. Here if I write A equal to 100, now it will be okay. But here when I write super dot A, that indicates it will go to super class and it will search for this variable. Okay, class level variables, not instance variables. So that as it is not there before, we got an error. Okay, so to access instance variables, compulsory we have to use self. So this is one example. So now let us go to second example here. So see here what we have seen here. Here I have taken only constructor here. Now I want to define one more constructor in superclass also. Okay, and just I will remove this one. Now I want to talk about constructors. I have shown you method. Now I want to talk about constructors. So init underscore underscore self I am going to consider here. Now in this I will take already here I have taken A. Let us take here B. I want to take different variables, right? Self.b I have taken just to indicate this as a parent class. I am going to leave it as parent class only. Now in this what I will do means, observe carefully, I will not do anything here. Just I will print, observe carefully, just I will print child class. First I will print only child class. Now if I execute this one, let us see what will be the output. So it has printed what? Only child class. The reason is you may think that it is a child class object. So as it is a child class object, we will go here and this will be executed. There will be no problem. Let us consider, I will delete this one. I will delete this one and just I will write pass here. Now what happens? So as here constructor is not there. Let us see what happens here. So see, parent class constructor is going to be printed. Reason is, here in our Python, constructor is also available for the child class. Whenever you are going to extend the properties of parent, then automatically this constructor is also available to the child. Now what happens here? Child object is created. So when child object is created, it will come to child class to execute constructor of child class. Is there any constructor of child class? Not there. But parent class constructor is available in this child. So this underscore underscore init is available in child class now. So whenever it is available in child class, what happens? This child class will execute that constructor only. If there is a constructor here, that means if some constructor is present in the child class, then this constructor only will be executed. Okay, now see, child class is going to be printed here. So one point we have to understand is what? If child class constructor is not returned and parent class constructor is available, then if we create a child class object, then automatically parent class constructor is going to be created. Now next point is, if you are going to consider child class constructor is present and parent class constructor is present, both are present now, then what happens? Child class constructor only will be executed. Last whatever the constructor we have written, already we have seen MRO. So first priority will be given to what? Child class constructor only. as we have seen there we have seen about methods. In the same way here, if you see, first it will be considered child class. If it is not present in child class, then only we will go to parent class. Okay, this is the first point we have to understand. Now you may get some doubt that, sir, if I want to access both the constructors, then no problem. Then see here when I created this child object, we will come to child class and we will execute this constructor. From this constructor, just I will call super dot underscore init underscore I will call. This indicates what? So as I am creating child class, I will go to this constructor. Inside this super dot underscore init underscore is nothing but what? It will go to its super class, which is nothing but parent class. In that it will execute init it will execute. That means this constructor will be executed. In that, what will be executed first? Parent class will be printed. After executing super class constructor, it will come back here and it will print child class. So the output of this program will be what? First it will print parent class and next it will print child class. Let us see now. So what happens? Parent class is printed and child class is printed. So in Java it is not possible. Okay, but in Python, here super class constructor is available to child class also. Okay, now if I want to, if I am going to write here, observe carefully. If I write here self dot b is already self dot b is available here, and if I write self dot b here as 20, now what happens? I will explain now. Listen carefully. When I'm going to call this one, what happens? Child class constructor is going to be called. In this, I am calling superclass constructor. So while calling this superclass constructor, one instance variable is created. Okay. After that, it is going to print some parent class. After it is coming back, again it has seen what? Self.b. On creating which object I came to this constructor? On creating this x. This object I came to this constructor. So self.b is nothing but what? X.b. Already in x we are having b value as 10. Again, if I write self.b equal to 20, then what happens? This 10 will be overridden with 20. Okay. If you want to see that output, just I will print it here. Okay. Just I will print it as, here I will print self.b once. Then you can see the output. So now see which one is printed. 20 is printed because it is overridden here. If that statement is not there, I will show you what is going to be printed. If that statement is not there here, that means I will comment this line now. Now what happens? Self.b is nothing but, sorry, if I comment this line, self.b means we are going to get 10 as output. So see here we got what? 10. Okay. So here if we write the instance variable once again, and if you are initializing, then what happens? Internally the value is going to be replaced. Already we know this concept in our instance variables. Next, we are having a. That means what? This a is there. How to access this a? This a can be accessed by using the, here we can observe, by using the object we can access, or by using the class name also we can access here. Let us see here. Here I want to access print of, so child.a. Observe carefully. Child.a means when child is extending the properties of parent, then all these are available to the child. That means the static variable, this class level variable also available to the child. Then what happens? If I call child.a, this 100 is going to be printed. Let us execute once. So what happens here? 100 is going to be printed. Okay. Next, if I want to call this one, if I want to call this one, then I can also call by using what? Super of I. What I can call? Print of super function I have to write here dot a I have to write. That's it. So in this case 100 will be printed. In this case also 100 is going to be printed. Now one point I want to discuss here. That point is, Here in these two cases, there is no problem. But if I write print of self dot a, then let us see what happens here. Self dot a. Okay, observe carefully here now. So what happens? Again, it is printing what? 100 only. Let us see why it is going to print the 100. Reason. Observe carefully here. I can access. See here. This is what? This is a constructor. Already this a value is available in the child now. That means what? Here a value is there. So I can access that particular a value from this constructor also by using self dot. Already we know, we have seen this concept in our class level variables. Okay, there we have observed there is nothing but static variables. We have seen how to access static variables. Okay, right. Next, if I call self dot b, what we got? We will get answer as 20 s. Now let us see in this program. In this program, if you observe, how many instance variables are there? Just I will remove all this concept. Just I want to talk only about instance variables. How many instance variables are going to be created here? First, when I call this init, one instance variable is going to be created here. That is, see, when this object is going to be created, what happened? Here we will come to this constructor and I'm calling superclass constructor. So control comes here, self dot b equal to 10. Then self is nothing but what now? X. So b equal to 10 will be created and parent class is going to be printed and control comes back to this line. So here what happens once again? Self dot b equal to 20 I am going to write. That means here 20 is going to be 10 is going to be replaced with 20. That means what can I say here? Only one copy of instance variable will be created here. That is nothing but what? The most recent copy which I am going to use. That copy only will be created. That is nothing but what? 20 I have used for that b. Okay, so that only that 20 will be there. Okay, this is a small example about super function. What are the members that can be accessed from the child class? Okay, of super class. From child class, what are the things that can access by using super function? We have seen now. Now, just I want to make you remember once again the points what we have discussed 2 sessions before. Those points are is a relationship and has a relationship. Just I want to discuss once because there is a link with this concept. So that just I want to discuss. That point is, when we are coming to the concept of inheritance, if just I want to make you remember these points. If you want to extend, existing features, that means superclass features, existing features or functionalities, then we have to use inheritance. Okay, just I want to make you remember. Then when we have to go to has a relationship, that means when we have to create an object, if you don't want additional properties, if you don't want additional features, just to access members of a class, then we have to use has a relationship. This is what inheritance is nothing but is a relationship. This one is what? Has a relationship. So we have to understand these 2 points. When I have to go for inheritance, when I have to go to this has a relationship, there is nothing but when we have to go for object, when we have to go for superclass, we have to understand. Just I want to make you clear that class A is there, here M1 is there, here M2 is there. Okay, one more class I am going to create. Now observe carefully here. I want this class require 3 functions where it should have M1 and M2 it require, and additionally it require third function. That means what? I am extending the functionality of this A. I will take this A, that means M1 and M2 are available for this B now, and I require A, that means here what I am doing, I am extending the functionality here, so I have to go for inheritance. Now next concept is, I don't want to extend the functionality, just I want to use this one, then just create object. Then by this is an object creation. So access a dot m1 and a dot m2. So when we want to access the members from a class without extending its functionality, I can go to as a relationship, or when we want to extend the functionalities of one class, then we have to go for the concept of is a relationship, which is nothing but inheritance. Okay, right. Now I will go back to our concept, that is our super. So now inside child class, from where I can use this super. Just now I have taken example, what just I have taken super here inside a constructor and I have used it. Now from where I can access, from a child class, or we can say, okay, from child class, or inside child class, we can consider where we can use super. The concept is what? From child class, or in child class, in child class, where we can use super function. This is the point now we have to discuss. That is from instance method. First one is what? From instance method, I can use this super function, and from constructor I can use, and from class method I can use. Let us see whether I can use or not. Just I'm writing different places. I have how to access those super class members. So first one is what? Instance methods. Here you can use, there is no problem. We can use what? Super. There is no restrictions here. We can use. Next, from the constructor also there is no restriction for super function. We can use without any restrictions. We can use. But when coming to this class method, or class method, here what we have to do? One very important point we have to understand. We cannot call parent class constructor. We cannot call parent class constructor by super. Okay, from class method. Here, see, we can call anything. There is no problem here. But from class method, if you want to use super function, so we cannot call parent class constructor by super. Next, we cannot call parent class instance method also, because it belongs to what? Class. So automatically when we consider class and instance, class and object, both are different. When we discuss about the concept of instances, generally we will talk about objects. Okay, so if we talk about class methods, it will talk about class, not about methods. So we cannot call parent class instance methods by using super, or by using super function. Next, but here one is possible, that is what? We can call parent class static and class members, or class methods by using super. Already we know about this class method, we have discussed in previous sessions. So you know what can be accessed from this class method, how it can be accessed, we know already. So in our super concept, where we can access super, I can access from instance method, I can access from constructor, I can access from class method. But here there is no restrictions for super here in our instance method and constructor. But in our class method we are having some restriction. That restriction is what? We cannot call parent class constructor. So generally when we talk about constructor and instance methods, we have to talk about objects. So from class methods we cannot call what? Constructor, and we cannot call instance methods. But what we can call? Class related things we can call. Class related things are nothing but what? Static and class methods. Okay, so these are the points we have to familiar with. Compulsory we have to understand this concept. So now I will take different type of scenarios to make you understand about this super function. Right, just I will take one class here. In that class I want to take a constructor. Just I want to make it as a constructor. Just here I will write constructor. Constructor I am going to write. Next, in child class, otherwise here only I will take one more function, that is m1 I will take, which is a instance method. Okay, right. Now in this, just I want to write what? Instance method. Just I want to show you what, by using super function, what all the things I can access in the parent class. Okay, right. Here I will write what? Instance method. Next, one more thing I want to take, that is nothing but what? Class method. That is what? Class method. So define, so for class method what I have to write? At the rate class method I have to write here. So I am defining this one as m2 now. So method 2, and here generally what we will use in a class method? CLS, one variable we are going to use. So here I will print what? I will print it as a class method. Class method. So this is a class, one parent class I have taken. In that I am going to take what? In that I am going to take three things. One is constructor, another one is instance method, third one is class method. Okay, one more method that is remaining, I will take that one also. There is nothing but static method. So no need of writing, it is not compulsory to write this particular decorator for these static methods, but to make understand, for making the user to understand, I will write that decorator also. So this is what? Static method. So to make you understand about this function, I am going to write what? At the rate static method. Is it compulsory for static methods? It is not compulsory. Is it compulsory for class methods? It is compulsory. So you have to understand this point. Already we have discussed all these concepts. Now, first case I am going to consider. From child class, I have discussed what here? I have discussed about these three things: instance method, constructor, and class method. First, I want to talk about constructor. So first case, I'm going to take what? Constructor I will take in a child class. So in child class, I'm going to take one constructor, and I will try to access all these members of super class. So here I'm going to define. Otherwise, according to the order, let us go here. Okay, instance method I will take first, then no problem. So define m1 in our subclass, child class. So from this, I want to call what? Superclass members. That is what I want to call. First member is what? A. So just I will call print of super dot A. Is it possible? Is there any restrictions here? There are no restrictions. Okay, you can observe here. Is there any restrictions? There are no restrictions here. Yes, let us check. Next one. Print of. So already I have taken one variable. Is there any other variable? No variable. So just I have to go for what? I have to go to these things. So now I want to call a constructor. So can I call it? There is no restriction, so I can call. There is no problem. Underscore underscore init underscore underscore. Yes, constructor can be called. Next, can I call superclass of instance method? Yes, let us see. Super dot m1, and I will also call super dot. Sorry, here I have tried open bracket and close bracket. Next here super dot m2 I will call, and also I will call super dot m3. So every method and members I have shown you. Why here I have not taken instance variable? Because if I want to access instance variable, there compulsory I have to use what? Self variable. But what we are talking about now, we are talking about super functions. So I am not discussing about those instance variables anymore. Okay, right. This is the concept. Now, first I have to create what? To access this, 1 minute. Okay, to access this method is present in where? Child class. So to access this method, I have to go to where? I have to go to sorry, I have to create an object of type child. So child I have created here. Now to execute all these calls, I have to call this m1 first. So just I will call x.m1. Now observe carefully. When I call this x.m1, what happens? It will go to this m1 and it will execute super.a. That means what will be printed? This particular a is going to be printed. That is 100 is printed. Next superclass constructor is going to be called. Constructor will be printed. M1 instance method is printed. Class method is printed, and static method will be printed. Now observe the output. So just here I want to make clear that is what from the instance method I can access any superclass member by using super function. That is the thing I want to make you clear here. Okay, that means what? This first point is cleared. This is working. There's no restrictions are there here. Next, I want to go to constructor. That is what constructor concept. Is there any restrictions here? There are no restrictions here. So what I will do? I will not change the program much. Just I will change this one to constructor underscore underscore init underscore underscore. Is there any need of calling x.m1 here? It is not required, because while child class constructor is going to be called, sorry, created, child class object is created, automatically this constructor is going to be called. Once this constructor is going to be called, all these statements are going to be executed. So will there be any restriction here? There is no restriction. Okay, but here what happens? This constructor is not executed once. Why this constructor? Here two times it is printed. Why here only once it is printed? Reason is, here in before case, when I call x.m1, constructor is going to be called how many times? Child class for creating once, and so just I will explain once again that one. So first we let us see about this concept. Later once again I will go back to that program and I will explain. Now here what happens? First, child class object is created. Child class object is created, and so it will call this one. When it is calling this one, it is going to print what? Super.a. That means this 100 is going to be printed. Next, super.init constructor is going to be printed. Observe here. Observe, constructor is printed. Next, what happens? Super.m1. M1 is what? Instance method. Next one, m2 class method. Next, m3 static method will be printed. So what happens here? Instance method, class method, and static method is printed. Okay. Now, in before case, why we got two constructors? I will explain now. Okay, there is small concept. Already we know that. Before what we have done, just here I am going to write instance method. That is nothing but m1. So here what I am doing? Just I am calling x.m1. So observe carefully. Here when I am going to, here what happens? One object I am going to create. An object I am going to create. When object is going to be created, first it will go to where? Child class, and it will search for what? It will search for a constructor. Is there any constructor in child class? So there is no constructor in child class. Then what it is going to do? It will go to super class. That means what? Super class constructor will be accessed. That means what? The super class constructor is available for this child class. So this constructor will be executed. That means what? First statement is printed as what? Constructor is printed. Next, x.m1. X.m1 means this is going to be executed. So first statement is what? 100 will be printed here. Next, what happens? Super.init. Once again, we are calling the same constructor. So here, once again, constructor is going to be printed. After that, m1, m2, m3, which is nothing but instance methods, class method, and static method. So in this way, the following program is going to be executed. So the output is what? Constructor, 100 constructor, instance method, classic method, and static method. Okay, right. So now two scenarios we have seen. First is what? First scenario is for instance method. Second scenario or second case is for what? Constructor we have seen. There are no restrictions here. So second point is also clear. So here no restrictions. Now I want to talk about this class method now. Okay. So just I want to show you about a class method. That means here I have to take a class method. Just I will make it as a class method. Okay, class method I am going to write. I will make this one as a CLS. Okay, we can keep it self, but it leads to confusion. Just I make it as a CLS. So what is not possible here? Observe carefully. What is not possible? We cannot call parent class constructor by super. Just I will show you only that case. Remaining things I will show step by step. I will remove all these cases. Now observe carefully. Now here, observe now. So here what happens? Init, super dot init, missing required on positional argument. That means, is it possible to call? Okay, let us take here with class name, let us call. There's no problem. Let us check now. Now what happens? Again, same mistake we are going to get. Reason is not this one. Reason is what? From the class method, I am trying to access. I am using what? Super. By using this super, I am calling what? Constructor. Is it possible? It is not possible. Already we have discussed that. We cannot call parent class constructor by super inside class method. Next point is what? First point is cleared. This one is completed. Next, we cannot call parent class instance methods. Now I will try to call parent class instance method. That is what? Parent class instance method is M1. Okay, just I will call here super dot M1. Super dot M1 I am going to call here. Now is it possible to call this one? Let us check. So let us call, right, what happens? M1 requires one required positional argument. So I cannot call this one from class method by using super. Okay, right. Next, I can also call by using, okay, I have shown you that. Okay, anyway, third point I will go. Third point, this is what? This is also cleared. Next, we can call parent class static and class methods. Just I will call two methods I will call at the same time. That is what? M2. M2 is class method. There is no problem. And also I will call what? Super dot M3 also. M3 is what? Static method. Is there any problem for these two? There is no problem. So answer will be what? Constructor by default it will be called. But remaining things we have to observe. That is what? Class method and static method. What happens whenever we are going to use this child object, when we are going to create this child object, automatically constructor is going to be called. Which class constructor? Child class constructor. But is there any child class constructor present? Not there. So super class constructor is going to be executed. So that first step is what? Constructor is going to be printed. After that, child.m1 is going to be called. So this m1 method is going to be called. In that first is what? M2. M2 is nothing but what? Class method will be printed. After that, M3 is called. What will be printed? Static method is going to be printed. So this is about in the different cases we have seen here. Now I want to show you about a static method. I want to take a static method and let us check what are the things that are possible here. Okay. So just I will, before going to explain that, I will write about static, but here I have discussed what? Only about instance method, constructor and class method. I forgot to discuss about static method. So in static method, if we write super, what happens? Let us see. So by taking a separate slide, I will explain clearly now. Now see, I am talking about what? Static. From static method. From static method. That means what? In child class, if you are going to write any static method, if you try to access super function from that static method, what happens? Let us see now. So we cannot use, first point directly I am telling that we cannot use super. No need of seeing all the cases, just directly I am telling one point that we cannot use super function inside a static method, because very important point, already while discussing static method I already discussed that this is just a utility method just for whatever the purpose. That means if I want to perform something, just for that purpose only I am going to create that static methods. It is not related to, generally what, it is not related to class or it is not related to object, so that we should not or we cannot use this super inside a static method. So generally what are the methods that are related to object and classes? So instance methods and class methods are related. So and class methods are related to our class and objects. So I can use super to this one, to these two things, there is no problem. But while coming to the static method, why we are going to write the static method generally to perform some task, that's it. So there is no relationship between these type of static methods and our class and objects. So if there is a relationship, I can talk about the super. So directly I can say what? Super class function, sorry, super function cannot be used inside your static method in child class. Let us try once. So we have seen all the cases. Just I will try with this static method also. To make you understand, I am writing here what? Static method. I have taken static m1 only. First thing is what? I will try to call m1. Super of m1 I will call. Is it possible? In any case, it is not possible. So in this case also, it is not possible. Is it possible? It is not possible. Next one is what? Oh, here, sorry, I have to remove this one also. Once again, I will execute. So now what happens? No super, no arguments is there. We are not getting. Just I will take what? M2. I will try with this. So M2 is also not possible. Next I will go to M3. M3 also not possible. Next, if I try a constructor underscore init underscore, let us try with this. So here also it is not possible. So finally, what we can understand here, we cannot we cannot use super function inside a static method of child class. So one more thing I have missed, I think that is nothing but super class variable. That is just I will write super of dot a I want to access. Let us try with this. I have shown you all the methods, but I want to show you about this variable also. So it is also not possible to access. So this is about super function. This is very important in our inheritance. So what we have seen in our inheritance concept. So we have seen about inheritance. Okay, inheritance we have completed. All concepts we have completed. In this we have seen the types. What are the types of inheritances? First one is single inheritance. Next one is multiple inheritance. And next one we have seen multi-level. Okay. Next one hierarchical. Okay. Next we have seen cyclic, which is not possible in our Python or Java. Next we have seen about hybrid. So when we discuss about all these up to the here, it is easy to perform these single level, multi-level and multiple level and hierarchical. But when we go for this hybrid, there is a chance of there is need of MRO algorithm. That is what method resolution order, it is required there. Reason, here in hybrid there is a multiple level of inheritance will be there. That means what? Multiple will be involved, multi-level will be there, hierarchical will be there. If there is a big hierarchy of classes is there, then we cannot say that which method is going to be executed if I call one particular method, from which class it has to execute. How we have to know that? By using the method called as C3 linearization algorithm. Okay, that means what? For method resolution order in Python, we are using what? C3 linearization algorithm, or we can call it as what? C3 algorithm. So already we have completed this one. So to access the superclass members from the child class, we can use what? Super function. In today's session, we have completed this concept also. Okay, right. So why we came to this inheritance concept? We are discussing about polymorphism. We are discussing about what? Polymorphism there. So in polymorphism, what we have seen? In polymorphism, we have seen operator overloading. Operator overloading we have completed. And after that, we have seen constructor overloading. Constructor overloading. Next. Now, after this, we have to see what? Okay, we have seen method overloading also. Overloading we have seen. For seeing overriding, first we have to understand inheritance. So that I have discussed entire thing about inheritance. So again in this overriding, we can see about overriding, method overriding, and we can also see constructor overriding also. So these two concepts I will discuss now. Okay. So we have completed the concept of inheritance, so that we know now how the inheritance, that means how the relationship between one class to another will be there. If I call the members of superclass from with child object, how it is going to execute, we know everything now. So now if I go to the concept of method overriding or constructor overriding, it is easy to understand. So let us see method overriding first. Okay, now we came back to our polymorphism once again. So what is meant by polymorphism? So one acting in multiple ways. Okay, one in many ways. So now we are talking about what? Method overriding. Okay, right. So already we know overloading. Okay, which is not possible in our Python. So there what we have seen, one method name, okay, different parameters. For example, int a, sorry, here we should not take what can I say, types here. So a comma b I am taking here. If I take m1 of a here, next m1 of empty here, so this is inside a class called as a, for example. So here this is called as a method overloading, but here if I call m1, what happens otherwise? If here I have written a comma b and here I have not written anything, if I call m1, so it will go to where? This one only. It will go to last method only. Already we have seen every concept about this method overloading. But what is meant by method overriding? Overriding means what? Just I will give a small example. I want to write good morning. So good morning, I am going to write here. So here I have written some spelling. You think that it is a wrong. You think that it is a wrong. So what you are going to write? You are going to override it. You are going to override it, and you are writing your own definition. When you are going to write this one, if you don't like this, you are going to write a new definition. Okay, that means what? If you are not satisfied with the superclass definition, you can write your own definition. Child class can write its own definition. So just I will, okay, before going to see, once again I want to briefly explain about this overloading. So how method overloading and constructor overloading can be implemented in our Python? It is not possible, but I can show you by using the concept of default arguments, and also I can use the concept of varargs, or we can say it as a variable number of arguments, variable arguments. By using these two concepts, we can implement our method overloading and constructor overloading in our Python. Now, coming to our overriding. First, I will talk about method overriding. I think this concept was clear to you. So first, if you understand what is meant by overriding, then we can go to our concept. What is meant by overriding? If something is written, which something is written by one person, let us consider it is written by a parent. It is written by what? Parent. So child don't want this definition. Okay, he want to change the definition for the good. So he's going to write his own definition. Okay, right. The concept is what? Just I will explain with with a statement, that is parent class methods and constructors available to the child class. We know according to the inheritance concept, what happens? Child, sorry, parent. 1 minute. Right. Now parent class members, or we can say parent class methods and constructors are available to whom? Child class. How it is available? Because it is by using the concept of inheritance, child class is going to get the properties of parent class. Now the concept is, here if child is not satisfied, with the parent class methods, that is what, here I have written some m1 and here I have written from m2. So child class will get these properties m1 and m2, but according to the child, m1 is not correct according to the child. So it can change the definition of m1. That means what? It is child is going to override the definition of m1. Okay, that means directly I can say what, if the method name is same here and in child class, and if you write some definition, it is nothing but a override. Okay, just a general example I will take here. Okay, general example I am going to take for this overriding. So observe carefully here. Just here I am going to take class parent and child to demonstrate about the concept of method overriding. So generally parents will give us what, their property they are going to give. So they want to give their property. So their property is what, he's my father is having, for example, he's having cash, uh, 50 lakhs cash he is having. So 50 lakhs he is having, 50 lakhs, and he's have he sorry and he have 2 kgs of gold, for example, 2 kgs of gold. Okay, right. Now next, he is having one more property, that is working property. Define working or work method he is having. So he will work to gain this 50 lakhs and 2 kgs gold. He has worked hard for 9 hours a day or 10 hours a day, for example, 10 hours a day. Okay, now child is going to take care about the property and his work. That means what, I can write what, child of parent. That means child is getting the properties of parent. That is what he is getting, the method called as property, and also work method he is going to get. What child will do, okay, he is a lazy person, for example, what he will take, just he will take the property from the parent. Okay, just what he will do, he will take a property. There is no issue about the property. He is not telling that I don't require property. He is not telling, because it's a free property, so that he is taking from his father. So there is no issue with the property. But coming to the work, child is a lazy person. So what he will do, so my father is telling to work 10 hours, but actually I don't want to work for 10 hours. I am changing my definition for the work. Whatever the father is telling about work, this child is going to change it as what, I will work only 2 hours a day, 2 hours a day. Okay, so that what here we have to understand, not about that working and properties, we have to understand about the overriding concept here. What overriding here, here two properties, these two are the methods that are given by the parent to the child. But child is not satisfied with this work, he is satisfied with this property. So he has not modified anything. He didn't tell about this, I don't want this property, or I require only 2 lakhs property. He is not telling. Okay, because he's a lazy person, he want the property, so he's not modifying the property. But he don't want to work whatever father is going to give to him. There is a father is telling 10 hours a day, but he don't want to do that, so he can override that method by writing what, 2 hours a day. Now observe carefully. Here I am creating a child object, that is what, x. That is what, x. So if I call x dot property, observe carefully, x dot property, which property is going to be executed? So first it will go to where, child class. Is there any child class property? Not there. So that you will take from where, parent class. That means what is the output of this one? 50 lakhs and 2 kgs gold is going to be given. That is nothing but printed. 1 minute. Here's some indentation problem we are having. Right. Now observe. So property takes 0 position arguments, but one was given. Oh, sorry, here just I want to change this one as a some instance methods. Self I will take, because I am calling with an object. So here I will take self. Here I am going to take self. Let us execute now. So what happens? It is going to give you what? 50 lakhs and 2 kgs gold. Because as child is taking the property from parent as it is going to print as it is. Now observe carefully. Now I want to execute work. I want to execute what? Work now. If I am going to execute work, Is work is available in the child? Yes. If it is available, what happens? This child method only will be executed. It will not go to parent class method. So what will be the answer now? 2 hours a day will be printed now. Observe carefully. So see what happens? 2 hours a day is going to be printed. Now the concept is, this is a lazy person. For example, now one hard worker is there. Hard worker, hard working son is there for that parent. What he will do? I can do. Father is telling what? 10 hours a day, but I want to work 12 hours a day. Okay, then what I will do? Whatever the parent giving to me, that is what? Super dot work. That means whatever the father is telling to work, I will work that, and additionally I will work what? 2 hours a day. Okay, so if I call x dot what happens? Then two methods are going to be executed. That is what? 10 hours a day and 2 hours a day. That means some people may be there, hard working sons will be there. So I want parent class method, and also I want the child class method. So inside a child class method, I can write what? Super dot work. So he's a hard working son, so that he's working for whatever father is telling. He's working 10 hours, and also additionally he's working what? 2 hours. Okay, so this is the concept of overriding, method overriding. Just for a small scenario, I have taken this example. So one point here we have to observe. What is that? Already we know super class. From the child class we can call, from child class methods we can call super class methods also, if we require it. If we don't require, I will remove this statement. Okay, right. This is about the concept of method overriding. Here I have overridden what? Method. Now I want to talk about what? Constructor overriding. Now I have to show you what? Only about constructors. Method is completed. Method overriding is completed. Now I want to show you about only constructor. Constructor means what? Define underscore init. So this is not possible in our Java. In Java it is not possible. It is possible in our Python only. So just here I am going to write what? Print of constructor I am going to take. This is which constructor? Parent constructor. So that I will write parent constructor I am going to write here. Okay, just I am going to write parent constructor. So for child also I will write what? Okay, first I will not write anything for the child. So just I will write pass. Pass means what? That class is empty. So first I am going to create child object. So what happens if I'm going to create only child object? It will go to child class to execute child class constructor. Is there any child class constructor? Not there. So as child is extending parent class, this parent class constructor is also available for this child. So that this child is going to execute what? This parent constructor. This observe carefully now. So we got what? Parent constructor is going to be executed. Now child is not satisfied with the child class constructor, so he want to override that. So underscore init underscore we are going to write what? Self. Okay, here init. So here it is going to write what? Its own definition. For example, print of child constructor. Just it's going to write what? Child constructor. Child constructor it is going to write. Now observe here carefully. Here whenever we are going to create a child class, it will go to child class. Is there any constructor here? Yes, there is a constructor here. So what happens? Child class constructor only will be executed. This is not going to be executed because child has overridden this constructor. Child has overridden this constructor and he has written some other definition. So the output will be what now? Child constructor will be the output. Okay. Now you may think that, sir, I need both parent and child constructor. Then don't worry. Write super dot call the super class constructor from this one. Init underscore. In this way we can call. Now what happens? Two are going to be executed. Parent class and child class constructors are going to be executed. So one thing we have to know here. So method overloading and constructor overloading is not possible. So if you try to overload method or if you try to overload constructor, then what happens? Last constructor or last method that has been written in your class is going to be considered. Next, so to show method overloading in our Python, we are using what? Default arguments. Or we have also seen what? We have seen two concepts. One is by using default arguments, and second one is by using the concept of what is that? Variable arguments, variable number of arguments. So anyway, just I will take one more example for this constructor overriding so that you will get a clarity. Because here I have taken what? Parent and child, just a small scenario I have taken here. Now I will take one employee. Okay, two classes I will take. One is class person I am going to take. Here I am going to take one constructor, define underscore underscore init underscore underscore. Here I am going to write self. Okay, right. Now in this, just I want to do what? I want to write the person's name and age. So person name equal to names. Already we know about how to initialize these variables. Self dot age equal to age. So these are what? Person details. So generally, next I will take one more class, that is what? A student, for example. I will take a student. So is student is a person or not? Yes, is a person. So that means I have to go to what? Inheritance concept. So I'm going to inheritance concept here. Now, is there any need of writing once again name and age here? Not required. Not required. But I need name and age also here. So that what I am writing, if I write init underscore underscore here, the meaning of this one is what? I am overriding superclass constructor here. If I override this one, name and age will be removed. So I don't want name and age to be removed. But additionally, I want student features like, okay, just here I will take some name comma, I will pass. While creating object, I will pass here. So that name comma, I will take age. Okay. Here, I will pass what? I want to pass everything here. First, I want to pass name, age of the student, and next his roll number. I want his roll number. Just I will write it as a roll, and his marks I want his marks. So these are the things I require. So self dot what I require? I require these two things also. So if I require those two things, what I have to call? I have to call superclass constructor. So that super function dot I want to call which one? Constructor init underscore underscore. Just I want to call with what? Two parameters. That is what? Name. Name means what? Just I have passed here some name I will pass. Age name comma age. Right. Remaining are what? Self dot roll and self dot marks. Self dot roll equal to roll and self dot marks equal to marks. Now just I want to display these things. For that I am going to write display. Display I am going to write here. So just display to display all these variables what I have taken here. Okay. Now observe carefully. Just I want to print what? All the details. What are the details we are having? Print of. First one is what? Student name, or just I'll print name. Name. Where it is? Name is present inside a self dot name. Self dot name. Next, in the same way, I want to print what? I want to print age. Age. I want to print age. So it is present in self dot age. Because self means what? It will give you roll number and marks and also name and age also. All right. Next one. Print of. I want to print what? Roll number. Just I will write roll here, comma self dot roll. Okay, right. Already we know how to access the members of instance variables. How to access the members of instance variables from the child class by using self. So to access this one, I can use self. There is no problem. Okay. Here I will take what? After roll number, I'm having marks. So just I will write marks. It is present in where? Self. How I have to access? Self dot marks. Don't confuse here. So as these two are available here itself, I can use self. Okay, so this should be what? This should be a instance variable, sorry, instance method. So see, self dot roll number, self dot marks, there is no problem. To access the members of superclass constructor also, I can use what? Self dot name and self dot age, because those are available here itself. I am calling the superclass constructor also. Okay, all right. Now what I have to do? Just I have to create a student object, student, and I have to pass four things. First one is what? Name I have to pass. Shiva I am passing. Next age I have to pass. And next I have to pass what? Roll number. Roll number I am passing. Next I want to pass what? Marks. Okay, right. Now while creating this one, what happens? While creating an object, these four arguments or parameters are going to pass to where? Marks will be passed to, see, name. Next 31 will be passed, sorry, Shiva will be passed to name, and 31 will pass it to age, and 50 will be passed to roll number, and 90 will be passed to marks. Then come to this one here now. Now there what happens? Init of name comma age, super dot init of name comma age. That means Shiva is passed here, 31 is passed here, and self dot name is what now? So object is creating. See here, object is created S. So here while constructing, we got what? Name, self dot name. So name will be created here as Shiva. Next what happens? Age will be passed as what? 31. After these two are going to be completed, once again it is going to come back to here. Here self dot roll equal to 50. Next self dot marks equal to 90. So here what happens? Marks equal to 90 is going to be created. So now all these are created in this statement. Now just I want to print them. So to print them, what I have to do? So I have to call this display method. Where this display method is available? Inside a student. So by using this S, I can call this display method. Now observe S dot display. What will be the output of this program? It will print all the data that is available in student object. So see, name Shiva, age 31, roll number 50, marks are 90. So this is about overriding. So with this, we have completed the concept of polymorphism. In polymorphism, we have seen what? We have seen in polymorphism, we have seen what? Operator, overloading. Next, we have seen method, overloading, and we have seen constructor overload, whether it is possible or not also we have seen, and we have shown you some of the other techniques also to implement these things. Okay, next method, overriding we have seen, and next constructor overriding also we have seen in this session. Overriding, this all comes under polymorphism, which is one of the principle of object oriented programming. Next, inheritance concepts also we have seen. Okay, with this we have completed two main principles of our object oriented programming. Those are inheritance and polymorphism. So in next session, we are going to see one more concept, one more principle of this object oriented programming, that is abstraction. So what is meant by abstraction and how it is implemented in our Python, we are going to see in next session. Thank you.